All right, so what we're gonna be starting off today is something called reference angles. Now, what I did here is I drew a unit circle, assuming you have a radius of 1. That makes it a full unit circle. And what I just did is I just said from this point up is 30 degrees. This is called theta. Theta is your degree, how much this unit moves to create a chunk of the circle. This angle that's connected to your origin is always called theta. So if theta is 30 degrees, we actually have a 30, 60, 90 degree triangle. So the very first thing I ask you is, what is tangent of 30 degrees in a unit circle? Well, remember, tangent is opposite over adjacent, which changes to 1/2 times 2 over root 3, which cancels out to give you 1 over root 3, and then you multiply it by that special form of 1. Remember how you simplify because you cannot have square root on the bottom. And you get root 3 over 3. So if you were to plug in tangent at 30 degrees, this is going to spit you out root 3 over 3. Okay, let's look at another question. Let's say we have, I'm going to draw a unit circle again. And the question is, what is sine of 60 degrees? Sine is 60. So here is my 1 unit radius. And I'm going to move this up. I'm going to create an angle I'm going to call theta, which is 60 degrees. So I'm going to say it's right here. This is 1 unit. And here's my radius of 1. And look, this is a unit circle. Now, if I were to draw my triangle straight down, make it a 90 degree, this is 60 degrees. This would be 30 degrees. Therefore, I'd have my unit triangle. Now, the side across from my 30 is always half of the radius, or half of the hypotenuse, which is actually the radius. Across from the 60 is root 3 over 2. Now, if I were to ask you, what is sine of 60 degrees? From theta, right here, it's opposite over hypotenuse, which is root 3 over 2, over 1, which is just root 3 over 2. Okay, now look at the next question on the thing of notes. I ask you, what is cosine of 150 degrees? Let's figure out where the heck 150 degrees is. Well, look, this is 90 degrees. If I were to go boop, straight up here, it'd be 90 degrees. This is 180 degrees. So it's in quadrant 2. So technically, if I were to move this and this angle right here would technically be 150 degrees. Now it's asking, look, here's your unit circle. If you were to go all the way around, still a unit circle. It's just by accident that it's not the same size as this. I'm just making it a little bigger so you can try to see what I'm doing. You got to figure out what is cosine of 150 degrees. So if you plug in your calculator cosine of 150 degrees, what is it going to give you? And this is when we need something called a reference angle. Anything that is not in quadrant 1 requires a reference angle. And look at the definition that I gave you for a reference angle. It's how many degrees it takes to get back to the, and I'm going to put this in huge lettering, X axis, not the Y axis. You're always going back to the X axis, not the Y axis. Okay, well, let's figure out a reference angle for 150 degrees. So if I were to take theta and I were to rotate it 150 degrees, I would end up at this location right here. What is your reference angle? How many degrees does it take to get back to the closest x-axis? Back to the, I should put closest x-axis, because technically you could go all the way backwards, but the closest x-axis is this right here, which is, if this is 150, this is 30 degrees to give me full 180 degrees. Okay, so we're going to look at this. We're going to come back to this question in a little bit. Let's look at some reference angles. If I were to ask you, what are some reference angles? Let's go across, let's say 135 degrees. Here's 90, and a little more is 135. This is from here to here. If I were to move this like this, this would be 135 degrees. What is a reference angle to get back to the closest x-axis? Well, 135 plus 45 degrees is 180. So my reference angle is 145 degrees. All right, let's try the next one. 210. Here is 90. Here's 180. This is 270 degrees right here. This is 180 degrees. This is 90 degrees. And this is the full 360 degrees. So where am I? What's my location at 210 degrees? Well, this is 90. This is 180. A little more. And I am at 210 degrees. What is my reference angle from 210? Look at the definition. The definition of the reference angle is, how many degrees is it to get back to the closest x-axis? How many degrees is it to get to the closest x-axis? This is the closest x-axis back here. So I was at 180 and I crossed to get to 210 to be at this location right here. How many degrees do I have to move this dude back to give me 180 to get to the 180 degrees? 30 degrees. That's my reference angle. It takes, if I'm at 210 degrees, I've crossed 180 degrees, 30 degrees to get to 210, so I've got to move it back 30 degrees. Okay, let's look at negative 45 degrees. Negative, this is always a positive rotation, counterclockwise. Negative degrees is a clockwise rotation. So technically, I'm going to go this way to get to negative 45 degrees. What is my reference angle from negative 45 degrees? Very, very simple again. Reference angle is, how many degrees does it take to get back to the closest x-axis? My reference angle from negative 45 degrees is a positive 45 degrees. Reference angles are always positive because technically this would be considered negative if you are going back. Don't think of it like that. It's just, how many degrees does it take to get back to the x-axis? All right, let's do this. Next one. You draw out the location of negative 120 degrees and try and state your reference angle. Pause the video and see if you can do this. Okay, let's see how you did. Negative 120 degrees. This is negative 90. Here is negative 180. So it's not quite here. It's just a little past negative 90. This is going to be negative 120. And this is how you draw it. You just always draw a little half moon and then an arrow where it stops. So if this is negative 120, what is my reference angle? How many degrees, if I'm at negative 20, do I need to get to the closest x-axis? I need 60 degrees. Notice this is still a negative rotation, but your reference angle is always a positive. So whether you have a positive or a negative original angle, your reference angle is just simple concept of how many degrees does it take to get back to the closest x-axis. Okay, the next one, it says negative 90 degrees. Your reference angle is 90 degrees. Okay, negative 90 degrees is boom, right here. How many degrees does it take to get back to the closest x-axis? Well, technically, since I'm in the dead middle, I can either go this way 90 degrees to get to my x-axis, or I can go this way 90 degrees to get to my x-axis. Don't worry, we're not going into quadratics or anything. It's not a parabola with a vertex or anything. It's just whether I go left or right, it's still 90 degrees to get to my reference angle. Okay. Now, I still haven't answered this question. The original question in the beginning of the notes was, what is cosine of 150 degrees? I still haven't answered that question. But look at the next part of the notes. It says to find a trig ratio of an angle, you're going to do 3 steps. Number 1, wherever you are, figure out your reference angle. So if I'm at 150 degrees, my reference angle is how many degrees it takes to get to the closest x-axis, which is 30 degrees. Number 2 is draw your triangle. Whoa, okay, look at this. Your triangle is always drawn where the reference angle is. Always. This reference angle is your theta. So this is 30 degrees. This is 60 degrees. This is 90 degrees. Now look, I'm going to redraw this over here. 30, 60, 90 degrees. Now, my radius is 1. The side across from my 30 is half of the radius, and the side across from the 60 is root 3 over 2. But there's one thing wrong on this. This side's 1/2. This side is root 3 over 2. But look, the distance from here to here is root 3 over 2. But this is your x-axis. It's actually a negative. Because if we were talking about this as a point, as a coordinate, a location, I technically have gone negative root 3 over 2 to the left and up 1/2. Now I can answer what cosine of 150 is. What is cosine of 150? It's the same thing as if you draw a reference angle of 30 degrees in this quadrant right here, then you use this triangle. Cosine is adjacent over hypotenuse, which is going to give me negative root 3 over 2. So if you plug in cosine of 150 degrees, you're going to get the same answer on your calculator as whatever negative root 3 over 2 is. Okay, now that I talked about this, we're going to do some examples. I have 5 examples that I'm going to go through with you. But I would definitely encourage you to try some of these on your own. Pause the video, try some of these on your own. Let's start off with sine of 135 degrees. All of these are going to require a reference angle. So here is 90 degrees. Here is, if I go 90 and I go 45 degrees more, I'm at 135 degrees, which is right here. My reference angle, step number 1, find your reference angle. I need 45 degrees more to get to 180 degrees. That is my reference angle, and I'm going to draw my triangle right here. This is a 45, 45, 90 degree triangle. You will always have a 30, 60, 90 or a 45, 45, 90 triangle that you end up drawing for this class, for every single reference angle, just to let you know. All right, so if this is 1, this side is root 2 over 2, root 2 over 2, but this side is a negative root 2 over 2. Now I can answer, what is sine of 45 degrees? Opposite over, sine of 35 degrees, which is the same thing as using your reference angle. Opposite over hypotenuse, which is root 2 over 2. Opposite side over hypotenuse. Root 2 over 2 divided by 1 is root 2 over 2. So if you would do sine, watch this. It's kind of a trip how everything works. If I were to go, make sure your calculator is in degrees, sine of 135 degrees. I'm going to get 0.707. It's the same thing as, let's do square root of 2 divided by 2. 0.707 is the exact same thing. That way you don't need a calculator, and I'm not going to allow you to use a calculator because I'm going to have you show your work. Okay, the next one is, let's figure out cosine of negative 45 degrees. Cosine of negative 45 degrees. Let's figure out our location. So I'm going to go negative, which is this way. 45 degrees. That means my reference angle is also 45 degrees. So here's my triangle. I'm going to draw my triangle. This is 45 degrees. This is 90. This is 45. So I'm going to redraw this right here just so it looks a little cleaner. If this is 1, this is root 2 over 2. This is root 2 over 2. But here's the thing. This is a positive root 2 over 2. This is a negative root 2 over 2 because I'm going down on my y. Now, what is cosine? Well, technically, we're using this angle. We're always using the angle from the origin. Root 2 over 2 divided by 1 is root 2 over 2. So check this out. Cosine of negative 45 is the exact same thing as sine of 135, which is root 2 over 2. If you don't believe me, let's try it. Let's go cosine of negative 45 degrees. 0.707, remember, is the exact same thing. Okay? Okay. Next one I'm going to do is tangent of negative 225 degrees. Tangent of negative 225. Negative just means you're going clockwise. So let's figure out the location. Here is negative 180, right here. Now, if I go here, it's negative 270, so it's halfway in between. I'm going to go from negative 180, another negative 45 degrees to get negative 225 degrees from here to here. So once I crossed negative 180 degrees, I crossed it by going a negative 45 degrees. So I have to go back 45 degrees. This is 45. This is 45. This is 90. Okay, so this side right here, this is my radius of 1, always. Root 2 over 2, this is a 45, 45, 90 degree triangle. But this is a negative root 2 because it's a negative x-axis. Positive on the y. What is tangent? Tangent of 45 degrees. A tangent of negative 225 is the same thing as this tangent of 45 degrees in the second quadrant, which is, from this angle right here, it's always where theta is in the middle. Notice it's always where theta is. It's always the middle angle. Opposite, root 2 over 2 over adjacent, negative root 2 over 2, which is going to give me, once I flip this and cross cancel, it's going to give me negative 1. So watch this. When I do tangent of negative 225, I get negative 1. See? That's why. Okay. We got 2 more questions to do. What is cosine of 750 degrees? I'm going to have you pause the camera. And I'm sorry, I want you to pause the video and see if you can figure out what cosine of 750 degrees is. Draw theta, draw where it is. Find your reference angle, draw your triangle, and solve. Okay, if you did that right now, cosine is it's 750 is a positive, so Technically, look, you are going one rotation, which is 360 degrees. We are a long ways away. If we go a second rotation all the way around, we are at 720 degrees. So I'm going to go up a little more to give me 750 degrees. How many more degrees did I go up from this x-axis? If I was at 360, 720, I went up 30 degrees more to get to 750. So that means my reference angle is, I got to go back 30 degrees. And here is my triangle right here. So cosine of 30 degrees, right here, that's your reference angle. It's the same thing as cosine of 750 degrees. It's the same thing. So cosine of 30, here's 1, this is 60 degrees. Here's your triangle right here. This is root 3 over 2. Cosine is adjacent over hypotenuse. So cosine of 750 degrees is root 3 over 2. Because root 3 over 2 divided by 1 is root 3 over 2. Okay, the very last one. Let's see if you can do this one. Tangent of negative 585. All right. Tangent of negative 585 degrees. Okay, let's try this. This is going to give me negative 360. If I go 90 more degrees, it's negative 450 right here. And if I go a little more back here, it's negative. Sorry, I'm just doing this on my calculator. So this is going to give me, if I go all the way 90 degrees more, it's going to give me 540 degrees. Okay. Now, this is 540 degrees. I need 585 degrees. So I'm at negative 360 minus another 180 is negative 540. I need to go up 45 degrees more, or negative 45 degrees, to get to negative 585. So my reference angle is I have to go back 45 degrees, giving me an isosceles right triangle. This is theta right here. So if my radius is 1, this is root 2 over 2. This is a negative root 2 over 2 because it's negative on my x-axis. What is tangent of negative 585? Which is the same thing as tangent of 45 degrees in a quadrant 2. Opposite over adjacent. Root 2 over 2 over negative root 2 over 2, which equals negative 1. So watch this. Tangent of negative 585. Let's see if we get negative 1. Tangent negative 585 equals, boom, negative 1. That's why, because the unit circle explains it. All with something called coming back, a reference angle. And it's always how many degrees it takes to get to the x-axis. Never go to the y. Never, never. See how I'm crossing it out with an x? Because I never go to the y. I always go with the x.